So now, here we have a really cool circuit. It's simple, but has a function that may be a little difficult to understand for a little bit. But the main thing is, we are setting basically 10 milliamps of current with this circuit. This is not as accurate as a multimeter, plus the integrated circuit uses a little bit of power. So this is the 78L05. The front is actually facing away from us. So we got in, ground, and then out when it comes to the pin layout, because we're looking at the back. And so in any case, it's setting 5 volts across this 510 ohm resistor, and it's warm. These can get really hot where it hurts to touch. So in any case, it's basically 500 ohms. It's 510, but 500 is close enough. 5 volts across 500 ohms is 10 milliamps of current, and so that current is going through this jumper to ground, but it doesn't have to. So it's keeping 5 volts between the output there and the ground pin, and that comes to this jumper, and then little jumper to this big jumper going to ground. So it's actually connected to ground right now, but it doesn't have to. Instead, we can come to an LED. Now you're going to notice that the current is actually going to drop, and hey, that pin just fell up. That never happened before. So yeah, I don't know how well you can see that, but the pin's right there. So I'm going to pluck that blue jumper, and I could have did this without recording, but I might as well record it. So yeah, there we got that pin. I did grab the green one, and just to save time, I didn't want to make you wait around while I grabbed it, even though it really wasn't that far. Okay, so yeah, we're back to 10 milliamps of current. So this is a current source. It's setting current. This is the current that we're setting plus whatever the integrated circuit uses. And what I was going to show is that this is with no load. So ground pin is going directly to ground. It doesn't have to. We can add an LED. There we go, just one LED. And you can see current did go down because you're going to need enough voltage in order to maintain that current. So we were at the limit, basically. This integrated circuit, the 78L05, which is a small version of the 7805. It needs about a couple of volts. And now the LED needs a couple of volts, and then we got 5 volts across the resistor. So I'm not going to do this, looking at each LED. We already showed, so I don't think 30 volts is going to hurt this integrated circuit. I wouldn't hold it very long though with the power demands of this, but yeah, 20 volts should be fine. So it's mostly enough voltage to power all of these LEDs now. So I can go one step at a time. I'll raise the power supply there just by touching each one of them. And I think that first LED might be the dimmest. Maybe that's the one that I put like 100 milliamps of current through by accident. That fried one of these resistors, completely burnt it up. I don't know if it caught fire or not. It was off to the side. I noticed smoke coming up from the cameras. But in case, as you use these, they get dimmer. So whichever one's the brightest probably got used the least, and can't really tell on camera too much. You can see them in person. There we go. Yeah, that one's the brightest one right there. When you put it like that, you can definitely see that when it's sideways. And yeah, these other ones on the ends are kind of dimmer, but we're not going to worry about that. There you can see, with 20 volts, we can power all of them. So that's 5 LEDs. You need at least 10 volts to light them up. We got 5 volts across the resistor. So that's 15 volts we need to account for. And then the regulator needs a couple volts. It loses that in the process. So right now, we only got like 3 extra volts or whatever. So the regulator is taking that extra voltage and just making waste heat right there. We're not conserving power. We're drawing 10 milliamps. Well, it says 11. So let's say 11 right there. This is probably using one of those milliamps. But 10 milliamps is going through those LEDs. So even though we're only setting 5 volts, it doesn't conserve power. If we go directly to ground there, this is just burning up all that voltage, making waste heat right there. Not burning like it's on fire, but it's waste heat, so wasted voltage. But the main thing is it's a current source. We set a current. Load doesn't matter as long as we got enough supply voltage to power that load. Otherwise, the load can change from nothing to a significant load right there. As long as it doesn't drop more voltage than what we got to power everything. So now, here is the schematic diagram, and if you want to lay it out like this, like I have here, remember you have to have it to the back. This is not a transistor, it's a voltage regulator, but it's in the TO92 package, which a lot of transistors are in. The bigger package, where it's more rectangle shape with the metal backing, is called the TO220 package. That can handle more power, and so with the heat sink especially, we could work with higher voltages, but in this case, that's where we're going to limit to. Again, that L means that it's one of these smaller ones. You could use just a 7805. That would work exactly the same. So the data sheet, though, for the L version, I think I only saw like one capacitor. So, and then the other one, if I added another one, you would set it right there to help stabilize that voltage across the resistor. But again, the load goes to ground, so it's just load there because it can be pretty much anything. All you got to remember is that it's going to drop from the supply voltage right there. So you always need 5 volts plus a couple volts for the regulator, and then whatever the load needs, you're going to need that. But it can be pretty much any amount higher than that, as long as you don't overheat the regulator. And that's... the regulator is going to absorb the extra voltage, 2 volts or more if it needs to absorb more. So we have any load that is possible, even a direct connection to ground right there. The regulator is setting 5 volts above the ground pin. That's called a ground pin. It's called common pin for the 7805, but again, works the same. Also with the 7805, the output and input pins are separate. So you'd be looking at the front of the 7805, whereas you're looking at the back of the 78L05. So sounds a little complicated. Main thing is whatever part you're looking, or whatever part you're working with, look at the data sheet. Always look at the data sheet. This is just a demonstration circuit that I'm showing you. It's not everything you need to know about this component. We're just covering basic stuff. All the grand details are on the data sheet. There's no point me telling you them because you can just read them yourself, and it's going to be more accurate if you read it directly. So yeah, basically 500 ohm resistor. It's going to set the current just a tiny bit lower, but it doesn't matter. These LEDs were the same brightness, whether they were 10 milliamps of current or 9.9 something. So we're just rounding. It's simple enough. 5 volts, 500 ohms. 10 milliamps of current. When you're doing the math, though, if you do the Ohm's law, make sure you do the math in amps. So again, I said a whole lot, but this is intended for absolute beginners, and so I hope everything I said was helpful. At some point, this all just becomes common sense for the most part, and so you just can look at a schematic like this and figure out how to use that with your own design, modify it generally slightly, but look at a whole bunch of schematics, and that's what I do right now. I got books, encyclopedia of schematic diagrams right there. I just flip through. So I'm not copying one that I found, but I found these basic principles on one of those schematics probably. This one I probably seen a long time before that. This was probably on the data sheet for the most part, and data sheets have schematic diagrams. So that's the other thing. Look at the diagram they give you and see how you can modify it to a way that is either useful to you or just something you want to try to experiment. Try to just build it to see if you can build it. So again, very long, but I hope you enjoyed. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.